Alright, today's video is over difference of squares, but what we need to actually do is do a warm-up of the greatest common factor first to make sure that we have that lesson in hand. So please go ahead and pause. I want you to try the 3 warm-up questions and then unpause when you are ready to check your answers. Alright, so remember that by doing the GCF, what you need to do is break it down into prime factorization. So what I notice here is that the GCF is going to be x, because both x squared and 2x share an x. If I were to factor this out, this would be x times x plus 2. Alright, so there is 4 x's here when it's x to the 4th, 3 here, and 2 here. So I share 2 all the way across. So the GCF here will be x squared. So the final answer would be x squared parentheses x squared plus x minus 1. That's because there's a minus in front of the x squared. So when I multiply x squared times negative 1, I'll get negative x squared again. Alright, now let's break down this one. Alright, so they all share a 3. So 3 in parentheses x squared plus 3x minus 6. Oh, and I'm sorry, the GCF was 3. Alright, so we begin by talking about difference of squares. Difference of squares is a special way of factoring, and there are certain rules that you have to follow before difference of squares can be applied. The first thing we need to know is, are there only 2 terms? In the case of the problem above, we have x squared and negative 16. There are 2 terms here, therefore we can use difference of squares. Now, is the first and the last term, are the only 2 terms that I have, are they perfect squares? So I look at x squared, and that's x times x. That is a perfect square. I look at 16, that is 4 times 4. That is a perfect square. A perfect square is anything that can be broken up into like x times x, 4 times 4, 5 times 5. Now, and we also need to know the last thing is, are we subtracting the 2 terms? Okay, so x squared minus 16 applies to all 3 of these properties, so we can use difference of squares on x squared minus 16. What that means is that you take the square root of the first term and the square root of the last term. So our problem was x squared minus 16. The square root of x squared is x, so that goes here and here. The square root of 16 is 4, so that goes here and here. And what you have is you have x minus 4, x plus 4. That is the factored form of x squared minus 16. If you multiply it back out, you'll notice x times x is x squared, x times 4 is 4x, negative 4 times x is negative 4x, and negative 4 times 4 is negative 16. Notice that 4x and negative 4x add to 0x. I'm left with x squared minus 16. So if you're uncertain of your answer, feel free to go back and do your multiplication to see, did you do it correctly? Alright, so let's find out if the following binomials fit the property of difference of squares. So the first rule is that it needs to have 2 terms. And I look at all 6 of these, they do have 2 terms. The second rule is that they need to be perfect squares. X squared and 1 are both perfect squares. I also need to subtract them. So since this has a subtraction sign, I am welcome to use difference of squares. So the square root of the first is x, the square root of the last is 1. So it's simply x minus 1, x plus 1. For number 2, 2 terms, both are perfect squares, x times x and 20 times 20. They are being subtracted, so I do the square root of the first minus the square root of the last times the square root of the first plus the square root of the last. Number 3, x squared and 4, there's two terms. They are both perfect squares, x times x and 2 times 2. However, we are not subtracting them, so we cannot use difference of squares. Alright, our next one, x to the 4th is x to the squared times x to the squared, or x to the 2nd times x to the 2nd. 36 is 6 times 6, so they are perfect squares. They are being subtracted, so it'll be x squared minus 6, x squared plus 6. Now I take a look at this binomial, and I notice I have x squared minus something. If this had been a perfect square, I would need to continue and do difference of squares one more time. However, this 6 is not a perfect square, so we cannot continue with the second difference of squares. Number 5, x squared is a perfect square, 48 is not, so we cannot use difference of squares. And last but not least, if you take a look at the hint, it says remember to do GCF first if necessary. Anytime we factor, the first thing we have to look for is the greatest common factor, every time. And what I notice is that there is a greatest common factor here. And that greatest common factor is 5. So I can actually pull out a 5 and get x squared plus 4, or excuse me, minus 4. That's a negative sign there. So I can actually take this one step farther because x squared and 4 are two terms. Okay, x squared is a perfect square, 4 is a perfect square. They are being subtracted, so it is 5, x minus 2, x plus 2. And this is your final answer. Don't forget to carry down the 5 for the GCF. If you don't, the answer is going to be different when you multiplied it back out. Alright, here are 3 questions that I'd like for you to try. Take a minute and see how well you do. Pause the video and then check your answers with me in a minute. Alright, so hopefully you've unpaused the video and you have your answers ready and waiting for me. If you take a look at all 3 of these, remember we have to follow the rules. Do they have 2 terms? So number 1, I have 2 terms. Is the first term and the last term, are they perfect squares? And the answer to that is yes, they are perfect squares. Are they being subtracted? The answer is yes to that. So the answer will be x minus 3, x plus 3. And that is the factored form of x squared minus 9. For number 2, we have x squared, so it would be x times x, and 36 is 6 times 6. 2 terms that are both perfect squares. They are being subtracted, so I can use the difference of squares. So it should be x minus 6, x plus 6. Alright, and the last problem, this is 2 times x, and this is 2 times 3. These are not perfect squares. However, I noticed that when I did my prime factorization that they share something. So what I can do is I can actually pull out a GCF of 2. And when I do that, the binomial that appears in the parentheses is actually a difference of squares. X squared and 9 are both perfect squares, and they are being subtracted. So your final answer here is 2, x minus 3, x plus 3. Alright, that's it for today over difference of squares. We will start by factoring x squared plus bx plus c in our next video. I will see you guys later.